Okay, so let's start with the challenge problem of the chapter 16. So this chapter is mostly is geometry transform, and so let's starting with the first one. Okay, so CD and is the image of AB and some rotations. Okay, so CD is the image of the AB with some rotations. There is a rotation angle and they share the same midpoint. Okay, so this is the AB, this is the CD, and this rotating, and they share the same common midpoint. Okay, so now let's see CD, the length is 2A, now the AB length is also 2A, right? Okay, so we want to see the M is the rotation center, right? So the rotation center, that means around the M, okay, A can rotate into C and B can rotate into D, okay? So in this case, we need to prove that this one equals this one with the angle of theta, right? And this one equals this one with the angle of theta, right? So that's why you can see we can prove the AMC is congruent to the BMD, and with the they are all isosceles triangles, right? So you can see, of course, M is the rotation center. Next. So you might recognize the diagram on the right. Okay, so the diagram here means so we have a square, and xy is x and y are midpoint of the AD and BC, and then we draw a quarter circle and intersect at O. Then we connect the AO and OC. Okay. So we want to use the principle we have explored to quickly find the angle AOC. Okay. So because we need to find the angle, right? So the side length doesn't matter. So let's see, the side length is 112. Okay. So the side length is 2, so we have this one is 2. Now let's connect in this point. Okay, let's connect in this one. So we know here is 2, here is 2, right? And and now we can also see the symmetry, right? I mean the triangle AOB is congruent triangle to the DOC, DOC, yes. And so we have this is the 90 degrees. This is also the median. So that's why the triangle AOD is the isosceles triangle, right? That means the AO equals DO equals 2. If this is the case, AO equals DO equals 2, then AD also equals 2. That means this triangle is an equilateral, right? So we get the AOD is an equilateral triangle. If it's an equilateral triangle, so here is the 60 degrees, here is the 30, 30, here is the 60 degrees, right? So now you can see, okay, because these two triangles are these two triangles are congruent, right? So you can see here is the 30 degrees. This is the 75, right? So this is the 75 degrees. So that's why the angle AOC is equal to the 60 degree plus the 75 degree is 135 degrees. Okay. If you just connected the DO and the CO, you can see the symmetry. This is how we solve this problem. Next is we have an octagon, Okay, the octagon is this. So we have the length of this. So we have the length of 2, and here is the length of the 1, and the 1. Okay, so this is 2, 2, 2, and all the internal angles are 135 degrees. Okay, let's do extension. So this way you need to know, okay, any kind of this kind of the octagon, the side length may not be exactly all the same, but this way we use the parallel line to cut it, cut a square. Okay, use the parallel line, cut square. Okay, then we can get this kind of the octagon. Okay, now let's using the A, B, C, D, E, F, G, H. Okay, now let's see this. After extending is P, Q, RS. Okay, so you can see after we extension, right? So this one is 45 degrees, right? And also the perpendicular, so this is 90 degrees, right? So now you can see, so this is 1 over root 2 and 1 over root 2, right? So after you extrapolating everything, you can see the PS equal the SR equals RQ equals QP, or equals the 2 plus root 2, right? So, and also you have a 90 degree here, right? So the PQRS is a square. Okay, so this is the first important results you can see. The second important results. Okay, so let's connect it the PQ and P. Let's connect PR and the QS. Okay, so now they are the diagonal of a square, right? So this is the center. So now you can see. Okay, so the HG. Okay, so think about it. The HG, right, have an angle of 45 here. The PR, because it's diagonal, also have 45 degree here, right? So you can see the HG is parallel to the PR is parallel to the CD. Okay, and but similarly, you can have the SQ is parallel to the EF, and also is parallel to the AB, right? And now if they are parallel, now you know this is the 90 degrees, right? They are 90 degrees. And because the triangle, let me draw this triangle to show you here. Okay, it's the PAB. Okay, so PAB is 1 over root 2. 1 over root 2 is 90 degrees. So this is a isosceles right triangle, right? So now you can see if this is the height, it's also it will also be the perpendicular bisector, right? This means the PR is a perpendicular bisector of AB, EF, and QS, right? The same thing is SQ is perpendicular bisector. Now this is 2. Now this is 3 is perpendicular bisector of CD and PR and HG. Okay, so now you see this perpendicular bisector. Okay, what's the properties of the perpendicular bisector? The property of the perpendicular bisector definitely means the OH equals OG. Okay, and definitely means the OA equals OB, right? But similarly, I mean, we can see the other thing. The only thing by symmetry you can see the only thing if we prove the OA equals the OH or whatever, okay, OH or OG, okay. But similarly, you can see every O, you can extrapolate, you can derive that OA equals OB equals OC equals OD. Okay, now let's see how we prove this. Okay, let me draw a triangle for you. Okay, take a look at the triangle, the PAO, and trying to see whether it's congruent to triangle PAO. Okay, SHO. Okay, let me use another color to show it. SHO. Okay, so now let's see. Okay, so here I have 45 degrees, I have 45 degrees. Okay, so 45 equals 45 degree, right? So this is the angle APO, and this is the angle the HSO. Okay, this is the first one, and second one you can see the OP equals OS. Okay, OP equals OS. Okay, third one is AP equals HS. Now they are congruent, right? So they are congruent means the OA equals OH. Okay, so yeah, so let's extend it this way. You can see these are all the congruent isosceles triangles. Okay, these 4 triangles. So by proving this, we prove that they are the same. So O is the center, right? Okay, O is center. Okay, now next is show the 90 degrees. Okay, that means if we rotate in 90 degrees, the original one can be to the new one. Okay, if we around the O, okay, the 90 degree, we can see after rotating, we prove that after 90 degree rotation, for example, rotating in this way, then H maps to B. Okay, then the G maps to A, then the F maps to H, and the E maps to G, so on and so forth. Okay, we want to prove that this is a B. Let me, yeah. Okay, so then let's see. Okay, so you can see because this is the isosceles triangle, right? So these are all the perpendicular bisectors. So these are also the angle bisectors. So theta and theta, theta and theta, because they are congruent triangles, right? So you can see the OS and OP are perpendicular, right? So that means the BOH. Okay, so angle BOH is equal to the 90 degrees, right? 90 degrees, that's the POS, right? That's the POS plus this theta minus this theta, right? Minus the angle HOS, then plus the angle POB, right? So equals 90 minus theta plus theta, so equals 90 degrees. Okay, so this means you after 90 degrees, okay, that means the H maps to B. Okay, but similarly, you can prove the rest of the 90 degrees. Okay, next. So A, B, C have a vertex of this. Okay, let's see. So the A is the 2 and 4. A is the 2 and 4. B is 6 and 4. So B is 6 and 4. Then C is 4 and 10. C is 4 and 10. Okay, so here we have a triangle ABC, and this is the midpoint, right? Then what we want to see is what will be the sum of the x coordinates of the vertices when it's reflected by the x equals 8. So this is the x equals 8, right? Okay, so this is symmetry, right? So here is the 2, this is the 2, right? And the A is reflected to here, right? So A to 2 to the 8 is 6, right? So this is the 6, and this symmetry is 6, right? This is the A prime, B prime, and this is the C prime. Okay. So now the coordinates of the B is the 8 plus 2 is 10, right? 8 plus 6 for the A is 14. Then 8 plus the C prime is the 4, right? 8 plus 4 is 12. So now you can see the sum of the x coordinates of the A prime, B prime, C prime is 10 plus 14 plus 12 is equal to the 24 plus 12 is 36. So the image of the incircle of the equilateral triangles upon dilation, okay, can be about the center of the circles with the scale factors. K is circumcircle, okay. So now, yeah, we always draw the circle first because the circle is hard to draw, right? Let's draw a circumcircle first, and inside the circumcircle, we know that for the equilateral triangle, the circumcenter, the incenter, and the centroid, the altitude, the orthocenter, they are all the same, right? So they all merge together. So this is the equilateral triangles. This is also the incenter and the circumcenter. So now let's see the radius. This is a small one, this is a big one, right? And we know this is also the angle bisector, this center, right? So this is the 30 degrees. So now the r over little r will be 2, okay? So K is 2. So use the clever dissections of the section is traced body left below to prove. Okay, so we have a regular octagon. Okay, let me draw a octagon. Okay, so we have a regular octagon is A, B, C, D, E, F, G, H. Okay, so we have a regular octagon. So I like to always extend it before the cutting of the octagon. Okay, the regular octagon is always cutting from a square. So I like to extend it to the square. Okay, so in this case, what you can see is we have the center of the O, right? So we know the center of the O is the A and the E, C and the G. Okay, so this is the O. Then we have the A, B, C, O. Okay, so we have the A, B, C, O, right? Yeah, we have the A, B, C, O, and A, B, C, D, E, F, G, H. Okay, so now let's calculate in this area. Okay, because it's the ratio, so it doesn't matter. Let's see, this is 1, then this is 1, right? Let's see the area of the octagon, right, is just the area of the extended square, right, minus the 4, 3, the equal, the isosceles right triangles. Okay, so this is the 1 over 2, this is the 1 over 2, right? This is the 1 over 2. Now we know the s square will be the 1 plus the root 2 of the square, right? Okay, then the equilateral triangle will be 4 of the, I mean, sorry, 4 of the isosceles right triangle will be 4 times the half times the 1 over root 2 times 1 over root 2. Then this will be 1, okay? So now we can calculate in the octagon will be the 3 plus 2 square root 2 minus 1, 2 plus 2 root 2. Okay. So now we want to calculate in the second part, right, of this. So you can see if we cutting like this, right? So each of this case is just a quarter ACEG. Oh, I'm sorry, no, ACEG. Okay. Oh, this one. Okay, so we want to calculate in the ACEG, right? So you can see if we calculate in the ACEG, and here is it's a square, then this is the 2 diagonals, right? So as long as we solve these 2 diagonals, we can solve it, right? Okay, so now let's see is the now let's see to solve the AC square. Okay, so we can see the AC square with from the right triangle. Okay. Okay, so you can see the AC square is equal to the 1 root 2 of the square plus the, it's 1 plus the 1 2 of the square. Okay, so it is also equal to the ACEG, right? Then this one is 1/2 plus the 1 plus the 1/2 plus the root 2. So this one is 2 plus root 2, right? Okay, so this one we can also say it's root 2, then root 2 plus 2, right? Okay, so that's why by comparing these two, you know the octagon is root 2 of the ACEG. Okay, next, so let's see. So we have it's a U shape, okay? And so we have this one is A is here, and but we know this is the 1 1, and the B is here is 1 1, right? And we have a beam, and this is the 2, this is 6, this is the 6, so this is the 2 2 2, 3 sections, right? So this is the 2, and this is the 5, this is the 2, so this is the 3 and 3, this is 5 and 5. Okay, it mentioned there is a beam of the A, right, and it goes to this mirror of the U shape, and finally achieve the B, right? So normally the mirror is you can bouncing like this and this or this, right? But it's asking you what is the minimum distance, right? The minimum distance normally want to bouncing as least as possible. Okay, so go this way, go this way, go this way, go this way. So if you can see this, right? If you go this way, that means we need to find the A prime, and also we need to find here is the B prime, right? So we can bounce in here and to here, right? So the thing is we need to find the point of the midpoint here, right? The easiest way you can do is you can just flip this one again. This is the A prime prime, and then you connected the A prime prime and the B prime. Okay, Okay, but the only thing what you need to make sure, okay, the only thing you need to make sure that this length, okay, is below this hypotenuse. Okay, how we prove that? Okay, let's do it. So this is the 1, right? This is the 1 and this is the 1, this is the b, right? So we can prove that by similar ratio, right? As let me give some point. Okay, p q r s. Okay, so we want to prove the qs over the a prime prime a double prime, okay, is less than, okay, the b prime q over the a prime b prime. Okay, because if they are similar, right? If they just on here, that means the triangle, the b prime q, this triangle is similar to big triangle, right? Let's calculate the ratio. So the qs is 3, the a prime prime, this is 5, this is a 5, so it's a 10. Well, whether it's less than the b prime q is 3, the a prime b prime is 6 plus 1 plus 1, right? Is 6 plus 2 is 3 over 8. Okay, so yes, right? Once we prime yes, so now we know, and then this one, the a double prime b is the shortest one, right? So you can connect it to this, right? Okay, you can connect this. So this is the p, this is the short shooting angles, right? You can connect here. I'm sorry, PQRST, right? So you can do this angle. So let's see, this is the C, this is the D, right? So now you can see the PC is equal to the A prime, sorry. The A prime AC is equal to the A prime C, right? And bouncing back to here. Yeah, and the dB prime is equal to the dB, right? So this is the shortest path. Okay, so now let's calculate in the shortest path. This one is simple now, right? It's by Pythagorean is the a prime double prime b prime equals to the 10 square plus what's this is 6 plus 8 square. Okay, so you go calculate it. Okay, next. So suppose the a prime and b a prime b prime have the same ratio, has a ratio, and they are parallel. So we want to prove the dilation. Okay. So why a prime and b prime intersect? Okay, so let's see. If the let's see. Okay, if the AB and the A prime B prime, if AB and the A prime B prime are parallel, right? Okay, if they don't intersect, means what? If they don't intersect means A prime also parallel to B prime, right? Then we also have the AB parallel to A prime B prime. That means the A B prime A prime is parallelogram. If this is the parallelogram, that means the A prime B prime equals to AB. That means the K equals 1. This is the contradiction. Okay, so this is the A. B is the P is the intersection. Okay, so they intersect at the P, right? So we can prove that because I mean these are parallel, so alpha, alpha, beta, beta, right? So you know the two triangles, right? The PA prime B prime and the triangle the PAB, right? You know the alpha equals alpha and the beta equals beta, then they are similar. Okay. Show dilation center. Okay, so the C is, we know the PA prime over the PA is equal to PB prime over the PB equals K, right? That means if this one is B prime, this one is A prime, now we know the A is equal to KA prime, B equals KB prime, so that's why it's a dilation. So ABCD be a square, and let M and N be the midpoint of AB and CD. Okay, it's A, B, C, D. Then let M, N be the midpoint of the AB and BC. Prove that CM is perpendicular to DN. Okay, so this is not that hard. Okay, let's see. So let's see. This is the 1. Okay, this is the 1. The side length is 2, right? So you can see that this one equal to this one. Okay, because it's the triangle CBM congruent to triangle DCN. Okay. So you can see, I mean, the one side length equals the other side length, right? 1 equals 1, right? And the 90 equals 90, right? So, but you need to know which angle, okay? So that's why they are congruent. Once they are congruent, then now let's see, okay? So the CD, if I rotating, okay, this triangle NCD by 90 degrees around the C, okay? So now that it's rotating, like it will be like this, right? The C will be here, the N1 will be here, and D1 will be here, right? So you can see the CD after rotating, the CD1, okay, is exactly BC, right? So that's why the BC corresponding sides is CD, they are perpendicular, okay? And the next one is the CN, is the okay. So next one is the CN, right? Yeah, CN. CD. Okay, CN. After CN rotating is CN1, right? CN1 will be parallel to BM, but that means it's corresponding sides BM is perpendicular to CN, right? So, and the two triangles after rotating, they are in parallel, like, right? So in this case, you know the triangle CD and the triangle BM MBC, okay, is a triangle. MBC is triangle NCD rotating 90 degrees. Okay, that means, I mean, that means these are perpendicular as well, right? Because after rotating 90 degrees, the D1C1, D1N1, okay, will parallel to CM. So that's why the DN is perpendicular to CM. Okay, so this is the rotation transform. Next, so the center of the cue ball on my rectangle pool. Okay, so I have a rectangle pool. The center of the cue ball cue ball is directly above the point A on the table. The center of the cue ball on my rectangle pool is directly above the point A on the table. I wished bouncing up the center of the ball will passing differently on the B. Center ball on a rectangle. Okay. Okay, so the center of the cue ball is on the A, right? And I wish to bouncing the ball off the rail, so the center of the ball will pass directly over the point B on the table. The radius of the cue ball is 1 inch, so the radius of the ball is 1 inch. A is 6 inches from the rail. A is 6 inches from the rail, and B is 9 inches from the rail. Let's pick a B that is 9 inches from the rail. That is B, and we want to find the nearest point on the point of the B, right? Nearest point rail to the point B. Do we want to? Okay, so let's see. It's the B prime. Let's say we want to bounce it to here. Let's say there is a ball. We want to bounce into here, right? This is the center, right? So we want the center passing the B, okay? Okay, so how we deal with this, okay? This is the B prime. Okay, so for example, this point is T. Is T, okay? We want to know what is the B prime T to make it happen, right? So if we draw a line here is parallel to the side, okay, we know this is the theta, this is the theta, okay, because this is the center, right? So this is a 1 inch, so the center get rid of the, there is a 1 inch shorter, right? So now let's draw another paragraph, another diagram with just with the center of the ball, okay? So this is the ball of the center of the ball, then this is the A, now this is only 5, right? And then this is the B, so B is only 8, okay? Then we need to find a point of the center that can get us to this, right? So here is the theta and the theta. Okay, so we know if this is the theta, right? We know they are parallel, okay? So this will be the theta and this will be the theta. Okay, then this is the 90 degrees, this is the 90 degrees, right? So the okay, then the A is 5 inches from the B. So the A and the B are 5, right? So now let's do let's draw a perpendicular line here, okay? So the first you can see here is the right triangle, right? So it's 5, so this is 3, so this is the 3, 4, 5 triangles. Okay, so that means this, the length of this is 4, okay? Now, because this is the T prime is here, right? The T, and once we figure out the T prime B double prime will be equal to the TB prime. Okay, so now we can work on this picture. Let's see, this is X. This is the 4 minus X, right? And we know the theta and the theta, right? Theta and the theta. So we know the T prime. We know the triangle, the T prime B prime will similar to triangle the T prime A A prime prime. Okay, so in this case, that means the x over the 8 is equal to the 4 minus x over 5. Okay, now let's solve this equation. So 5x equal to 32 minus 8x. So x equals to 32 over 13. Next. So what is the total length of the shortest path go from the 0, 4 to a point on the x-axis? Okay, so we have the 0 and the 4, 0 and 4 to a point on the x-axis, then to a point on the y equals 6. So from here to here, and then to the 18.4. So we want to find this bouncing to here, right? So you can see for the first bouncing, right, we need to do the A prime. So that's the 0 and negative 4, right? And for the second bouncing, we need to do this, right? This equals this, so we do the B prime. That one is this is the 2, so it's 18, and 6 plus 2 is 8, right? So now you connected this line. This is the shortest line, see? 1, 2. Okay, so this is the PQ. Okay, so when you bounce in, so this angle equals this angle equals this angle, right? So the shortest path will be the A prime B prime is equal to the 18 square plus the 12 square. Okay. This one is equal to 6 root 13. So problem 52. Okay, so I'm standing in the point of the A. On the right, I wish to walk to the point BC, and then to a point BD, then back to A. Okay, so what is the shortest distance? The same thing. So this is the A prime, the A prime prime. So we can connect it to this one, right? So then when you walk to the point here, okay, this is the P, this is the Q. So A P is equal to the A prime P, then A Q is equal to the A prime prime Q. Then you can see the AP plus PQ plus QA is shortest is A prime prime, right? Next is a regular octahedron. You know the volume of the regular octahedron is 360. And what is the volume of the portion that octahedron consists of all the points that are closer to point A than to any other vertices? Okay, vertex. Let's draw a regular octahedron first. Okay, we only need to draw half of them, okay, because by symmetry, okay, you can see the bottom half is the same, okay. Okay, you think, okay, first is it's closest to A than the rest of them, right? Means if by taking off the A, right, we have the shortest distance, okay? So we have the distance to A is less than the shortest distance of the to the B, C, D, E, F, right? Yeah. So now you can see the symmetry here, right? So the first is what kind of things is the minimum of to the one of the, what is the minimum of the one of the point? What's the region, right? So let's cutting this the bottom of the along the center to cut the bottom of the this square. Okay, so this is the B, C, D, E. Okay, so the closest one to the B, C, D, E, right? It should be in this region. If I have my point, if my point is within the region of the A, then OMCN, right? So my closest, I mean on this side, right? The smallest is DC. Did you see it? Make sure you can see it. Okay, it's DC, right? So we want to make sure this one is less, right? So now let's do it. So we know from the AC and AB, right, is the perpendicular bisector, right? We draw perpendicular bisector, okay? So let's choose another color. So these two are intersecting at this point on the surface, right? So, and also we can draw the perpendicular bisector here, right? Okay, so we know that the points on the edge is we need to connecting every single point, okay, inside this region. Then you can see in the center, right? Could be the center should be down, right? A little bit down, right? Yeah, because I mean because we need we need to calculating what's this the height of this square plus this square is this square, right? Is less than this square. So you can see it's a irregular. All these points are consisting by the irregular shape, right? But if you think about it, okay, all these faces, all these cutting faces, right? They are, if you go across this point, I mean this face, I mean they are closest to C instead of closest to A, right? Okay, so the symmetry is very important here. Okay, so you can see, okay, so the shape, okay, the volume shape, okay, closest to A is also congruent to that shape, congruent to B, C, D, E, and F, right? Because I mean, if you're passing through the face point, it becomes the closest to the next one, right? To the other ones. So that's why you totally have 6 such cutting things, right? The 6 solid shapes, they are exactly identical. 6 solid shape connect each other and congruent. Okay, so that's why the volume becomes 360 over 6 should be 60. Okay, so be sure you can see the symmetry here. Next. So next is in the diagram. We have the, let me draw it. So we have the ABC. We have the ABC and the QAR. and RPB and PNQ. Okay, so they are equilateral triangles. So we want to prove the BQ equals the RN equals the AP, okay? Okay, first let's parameterize this, okay? So let's see, this side length is PP, this side length is N, then this side length is MMM. Okay, then this side length will be the N minus, will be the, this is also the M, right? And this will be the N, okay? And we also have a lot of 60 degrees, okay? So now let's construct some triangles, okay? So let me draw the first triangle, okay? The APR. Let me draw the second triangle. Okay, so let's see. Triangle PRA, triangle BRQ. Okay, so we have the RA and the RQ equals N. We have the RP equals RB equals M. Then we have the angle RQ, no, PRA equals the angle BRQ equals to the angle 60 plus, let's see, this is alpha. Okay, so we can prove they are congruent, right? It's SAS rule. Then we can prove the AP equals BQ. Okay, so similarly, you can choose another one. Okay, let's see the CR. And CR and BQ, okay? So we can prove that triangle CQR is congruent to the triangle CQR is congruent to triangle the CQR is PQA, okay? You can also prove this. Then you can prove the CR equals the AP, okay? Then by combining together is AP equals BQ equals CR. Okay. Next. So we want to prove that the image of a circle and the rotation is also a circle. Okay. So let's draw a circle and another circle. Okay. Let's see the rotation. Let's see the PAB, and we're rotating it to the PA prime B prime. And let's do the PCD. It's rotating to PC prime D prime. Okay, so now we have the angle of the theta and another angle also of the theta, right? So we want to prove that we know that because they are rotation, right? PA equals PA prime, then PB equals PB prime, then PC equals PC prime, PD equals PD prime, right? We know that this ABCD are concyclic. And we want to prove the A prime, B prime, C prime, D prime are also concyclic, okay? How to do this, okay? I talked that before in 中文叫切割弦定理 ，OK？ 切割弦定理 In English is PowerPoint. Okay, so when we do the PowerPoint, we can see the PA times the PB equal to PC times PD. So we can see this the ABCD concyclic. Oh, once you have the ABCD concyclic, you can get this. Once you have this, you can get ABCD concyclic. Now we have the PA prime times PB prime equals to PC prime times PD prime, right? Because this one equals this one, right? And this one equals this one. Then you can see the A prime, B prime, C prime, D prime concyclic. Okay, so that's it for the challenge problem of this chapter. Thank you.